All right, we are gonna move on to 7.6, which is the fifth lesson of this unit. We are gonna be transforming log functions, okay? So before we do that, again, we're gonna quickly review what we did last time, which was the laws of logarithms. Okay, so hopefully you recall, if you have subtraction of two logs, what we can do is we can simply divide the numbers, okay? So 2 divided by 4, so that's gonna be log of 1/2. And when we have additions of two logs, we can simply multiply the numbers. So this is going to be 12 times 8. So this is going to be log of 96. Finally, we can always bring the coefficient to the exponent position. So it's going to be 36 to the power of 1/2. And now, if you recall, to the power of 1/2 simply means square root of 36. So this is going to be log of 6. Okay, so that's what we did last time. These were the 3 rules that we looked at last time. Okay, we are going to look at one additional rule, which is the change of base rule. Okay, so here is log base b of x. You can actually change this into a fraction, okay, a division of 2 different logs and you can change the base. Okay, so that's the key, right? Because you can see this is what base b. We can change it to base a. Okay, now a could be any base. Again, as long as a is not 0, it's bigger than 0. Yeah, that's right. So it's bigger than 0, so it doesn't equal to 0, and it's not equal to 1. Okay, so you can see here, it has to be bigger than 0, and a cannot equal to 1. And of course, x would have to be bigger than 0 as well, because we cannot log negative numbers. Okay, so we can change the base. So from a base that's given to you, you can change to any base you want. Okay, so sometimes this is helpful, could be useful when we simplify things. Okay, so that's the last rule that I'm showing you. Oh, it says let's prove this formula. I think we'll pass. Okay, we'll pass. I think we'll pass. It says use a calculator to evaluate the following logarithms to the nearest thousands. So then this, you can convert this into 2 different logs. So again, in your calculator, if your calculator has this button, just log. If it just log, that means it's base 10. Now this is base 2, so we can't evaluate this. Okay, so what we need to do is we need to change this to base 10. So we can change this to base 10, but then this will become a division of 2 logs, and one of them is going to be log 100, and the other one is going to be log 2. So again, you can see from the rule here, x is the one on the top, the base is the number we're taking the log of in the denominator. Okay, so here, log base 2 of 100 is the same thing as log base 10 of 100 divided by log base 10 of 2. Of course, again, you do not need to write down the base 10. I'm just showing you that I'm changing to base 10. Hopefully, you'll be able to evaluate this. Log base 10 of 100 is a 2 because 10 squared is 100. This is not a nice number, so now what you need to do is to put that into a calculator. Log 2, that's 0.3-ish, and now we can put this into a calculator. You should use the enter button on your calculator, not 0.3 though. Okay, so you should get 6.644. Okay, so similarly, you can do it for part B. You can change this into log 5 divided by log 3. So notice how I change everything to base 10. Again, 5 goes to the numerator, the base goes to the denominator. Now you can put this into a calculator. I don't know what this is. Log 5 divided by log 3. You should get 1.465. Okay. Last one, again, same thing. This will be log quarter divided by log 3. I don't know what this is. Log 0.25 divided by log 3. Oops. Log 3. You should get negative 1.262. Okay, so that's what you can do with the changing the base rule. All right, so that's kind of the it's kind of the extension of what we did last time. I just don't want to give you too many rules at once. Now we're going to transform functions. Okay, so we should be familiar with this by now. Okay, so again, the general form for transformation done for the exponential function, hopefully you recall, it was y equals a times k to the power of b times x minus c, and then plus d. Right? This was the transformation for exponential function. Guess what? It's going to be similar for log function. Okay, so if we had y equals log base k of x, then the transformation is going to be y equals a log base k, that's not going to change, x minus c, and then plus d. I'm going to put a bracket here as well. Okay, so again, log base k of x, that was the original function. Notice how I move, there's a c, so moving sideways. Oh, I forgot b. I forgot about b. Okay, so log b of x minus c plus d. There you go. I forgot about b. So notice how it was just log base kx. Now I added the b there and the c there, so there's a horizontal expansion compression depending on what the value of b is, and c sideways, moving sideways, a vertical expansion or compression, d is just moving up or down. Okay, you can see it right here actually. Okay, so, and here again. I just want to see it more than once, okay? So k is bigger than 0. Again, the base has to be bigger than 0 and not equal to 1. A, B, C, D's are just constants, and A and B cannot equal to 0, because otherwise we're going to end up with log of 0, which doesn't do anything. Actually, you can't even log 0, so that doesn't make any sense. And A cannot equal to 0, otherwise the whole function becomes 0, so it becomes a horizontal line, right? So then that doesn't work either. So A and B cannot equal to 0. Okay, so we would have a vertical expansion or compression by a factor of A, or absolute value of A. We would have expansion and compression horizontally by a factor of, recall this was 1 over b, absolute value of 1 over b, if we don't think about the reflections, 1 over b. Reflected in the x-axis when a is less than 0. Reflection in the y-axis if b is less than 0. We would have translation of d units vertically and c units horizontally. Okay, so if it was x minus 5, it's 5 units to the right. X plus 5 means 5 units to the left. Okay, so again, this should be quite familiar for you to see. Okay, so x comma y becomes x over b plus c, and the y coordinate becomes ay plus d. Yeah, all the things that we've seen before. All right, so now we're going to actually do some transformation now. Okay, so part A says create a table of values for y equals to log base 4 of x. Okay, so recall when we have this, we still create the table of values. But remember, instead of having the x values set first, we make the y values to be -1, 0, and 1. And the x will be 4. So remember, this is equivalent to 4 to the power of y is x. So now this x value will be 4 to the power of -1, which is a quarter. 4 to the power of 0 is 1. 4 to the power of 1 is 4. So that's the table value for y equals log base 4 of x. Okay, now we are going to, well, I guess we need to sketch both. So I'm going to draw this one first. A quarter and -1 is somewhere here. 1, 0 is here. 4, 1, 2, 3, 4, and 1 is right here. Don't forget your vertical asymptote. Okay, now I'm going to change the color. Draw green. Now I am going to have the x, and this one is going to be y equals log base 4. Again, notice how this is 2x plus 4. Recall, we always factor out the value of b first. Okay. So let's see what's happening now. Well, we have the value of b, we have the value of c. Okay, so remember the value of b and c, they affect the x values. So we didn't actually have any value of a here or value of b right there. So that means there's no change in the y values. So actually my new y values will be the same as the old y values. Okay, but for my new x values, it's going to be different. Okay, because the value of b is 2. So remember, again, x becomes x over b plus c. And this time, it's going to be the value of b was a 2. So x divided by 2 plus c. In this case, is x plus 2. So remember, c is actually -2. Okay, so horizontal compression by half, and then move 2 units left. So we're going to take these x values, and then we're going to do the following transformation. So a quarter divided by 2 is an eighth, and then 1/8 minus 2 is negative 15 over 8, or negative 1.875. I'll write it over a little bit more. Negative 15 over 8, or negative 1.875. 1 divided by 2 is half, minus 2 is negative 1.5. 4 divided by 2 is 0, 2 minus 2 is 0. So there we go. We have our new coordinates, negative 1.875 and negative 1. That'll be somewhere here. Negative 1.5 and 0 is here. 0 and 1 is here. Now, our vertical asymptote has been moved 2 units left, right? Right there, it's moved 2 units left. So here is my new vertical asymptote, and here is my new graph. Okay, so that's my graph. Okay, that's part B. Part C says identify the intercepts, the equation of the asymptote, and then domain and range of the new function or the new graph. Okay, so this is part B. Part C. This is part A. Part C, we are looking for the intercepts. So you can see we have the X intercept right there. We actually have 2 intercepts. We have both X and Y intercept, and you can actually see from the table right here. So we have the X intercept, which is negative 1.5. Y intercept is 1. We have vertical asymptote, it's now shifted to the left by 2 units, so then x equals to negative 2. Domain is now greater than negative 2, and range will be all real numbers, okay? So hopefully you still remember the basic graph of the log functions, and then again we just apply the knowledge that we gained or learned from the previous unit transformation, and we are applying those knowledge to different function, which is the log function right here, okay? Finding x-intercept and y-intercept could be tricky, and I'll show you how to do it later if it doesn't actually show up on our table, okay? So what I'm going to ask you to do is try this one, and then see how we do, okay? Good luck. All right, so first you should come up with the table for y equals log. So I'm doing this one right here. And remember, we set the y values first, negative 1, 0, and 1. So that's going to be 1/2, 1, and 2. And then we're going to take that. Okay. Again, what you need to think about for this one is that 2 to the power of y is equal to x. Right? So you can get the table of values right here from the exponential form. Much easier. Okay. Now, I'm going to do this one right here. So now notice we have the value of A and the value of D. There's no value of B or C. Okay, so that means the X values will actually remain the same. 1/2, 1, and 2. However, we will have different Y values now, right? So remember, it was Y. This becomes a y plus d. So in this case, it's going to be negative 3 times y plus 1. Okay, so negative 3 times negative 1 is 3. 3 plus 1 is 4. Negative 3 times 0 is 0. 0 plus 1 is 1. And negative 3 plus 1 is negative 3 times 1 is negative 3. Plus 1 is negative 2. So, oh, I guess we need to graph both. Okay, no, I'm gonna skip the log base 2x graph. I'm just going to graph the red one, the transform graph. So 1/2 and 4, 1, 2, 3, 4 right here. 1 and 1, that's right here. 2, 1, 2, and negative 2 is right here. Now, because there is no horizontal translation, so our vertical asymptote is not going to move. Okay, so our vertical asymptote remains right here, and therefore this is our graph. Looks something like this. Okay. Now, notice how we do not have, well, I mean, look from the graph, we don't have a y-intercept. We do have an x-intercept, but you can't tell from this table of value. So what do? Okay, well, remember to find x-intercept, what we do is we make y 0, right? So that's exactly what I'm gonna do, okay? So I'm gonna say 0 is equal to -3 log base 2 of x plus 1. And now from here, I can solve for x. So I'm gonna move 1 to the left, so that's -1 equals -3 log base 2 of x divided by -3 on both sides, you got 1/3, is equal to log base 2 of x. Finally, we can solve for x by changing this back to the exponential form. So this in the exponential form is 2 to the power of 1/3 is equal to x. And now you can, this is simply cube root of x. Cube root of 3, right? Cube root of 2, right? To the power of 1/3, so this is cube root of 2. Okay, so we have our x-intercept, which is cube root of 2. If you want to put this into a calculator, you can get a decimal. Sure, that's fine. Let me put that in the calculator and see what I get. You should get 1.26. Okay. What else do we need to find? The asymptote. We still have the vertical asymptote and actually didn't move. It was still x equal to 0. Domain, in that case, will remain the same, bigger than 0. Range is going to be all real numbers. Okay. So that's the answer for this one. Okay, so that's it. Here's the last one. Good luck. It's like there's a lot of transformation. You got all A, B, C, D values here. You're just going to combine all of them together. I know you can do it, so give it a try. Good luck. All right, here we go. So the last one, what we need to do first is get your original table values, which I did, and I actually graphed it already right there. Now the next part is we need to sort this out. So be careful. Remember, you have to factor the values of b out first. It's going to be -3 and then x minus 3 minus 1. So there's our A, B, C, and D. So our x becomes x over b plus c, so x over -3 plus 3. And the y values becomes ay, so 2y plus d, 2y minus 1. So here is the new table values. Okay, so for x values, 1/2 divided by -3, that's going to be -1/6 plus 3, so that's going to be, what is it, 17 over 6. Okay, and then we have 1 divided by -3 is -1/3 plus 3, which is, what is it, 8 out of 3? Yes, 8 out of 3. And then 2 divided by -3 plus 3, which is going to be 7 out of 3. Okay. Ooh. Okay, let's see. And then we have the y values. So 2 times -1 is -2, minus 1 is -3. This is going to be -1. 2 times 1 minus 1 is 1. Okay. All right, sorry I had a quick water break. Okay, so now we can actually plot these points, and let's see what happens. So we have, okay, 17 over 6. If you put that into a calculator, that's almost 3. So 1, 2, 3, and -3. 1, 2, 3, so it'll be somewhere here. 8 out of 3 is also almost 3. That's 2.6 repeating, and -1, so that's here. 7 out of 3 is 2.3 repeating, and 1, so that's right here. Okay, so it's almost like a straight line. Okay, now our new vertical asymptote, because we are moving 3 units to the right, x minus 3 tells us the graph has been translated 3 units to the right. So our vertical asymptote is now going to be right here. So here is the graph. It looks something like this. Okay, so something like that. Okay. All right. Now, here is the problem, or here are the problems, right? We don't have x-intercept, we don't have y-intercept, but we don't have the values of them, but we know we do have them, okay? So I think, again, we can find x-intercept by making y 0. I think y-intercept is rather easy to find. We can simply plug in 0 into x. So that's what I'm going to do. So to find my y-intercept, I'm going to put 0 into x. base 2, negative 3 times 0 plus 9 minus 1. Now you probably need to put this into calculator because this becomes 2 log base 2 of 9 minus 1. And negative 3 times 0 is 0, plus 9 is 9. We can then change this into a different base. This is going to be log 9 divided by log 2 with base 10. Okay, so now you can put this into calculator because I have no idea what this is. 2 times log 9 divided by log 2, and then minus 1. The y-intercept is approximately 5.34. Okay, so that's my y-intercept. Now for my x-intercept, again, that means I need to make y 0 and solve for x. So here's my equation. I'm going to make y 0. So I have 0 equals 2 log base 2, negative 3x plus 9 minus 1. Okay, so same thing, move the 1 to the left, so you get 1, and then divided by 2, so 1/2 is equal to log base 2 of negative 3x plus 9. We can then change this into exponential form, so this would be 2 to the power of 1/2 equals negative 3x plus 9. Recall 2 to the power of 1/2 means square root of 2, so this is root 2, and then move the 9 to the left becomes minus 9 divided by equals to negative 3x, and therefore x is going to be root 2 minus 9 divided by negative 3. You can leave your answer like this. I'm perfectly okay with that. Or if you really want to put it into a calculator, that's also fine too. And same thing, I think if you just leave your answer, maybe not. Either way, really, either way, you can leave it like this too for your y-intercept if you want. I'm going to put it into a calculator, okay, just to show you what it is. Root 2 minus 9 divided by negative 3. This is 2.53. Okay. Domain, you can see the graph is actually on the left-hand side of the asymptote here. So your domain is actually x is less than 3 now. Okay, it's not greater than because it's on the left-hand side, so it's actually less than 3. Range will not change. This is still y is element of all real numbers. Okay, so there is your part D or part C. Okay, that's it for today. It's not really something new. We are just really combining two things that we learned in the past, right? The log graph and the transformation, and we put these two together, and that's what we did today, transformation of log functions. Okay, that's it for today. If you need some help, let me know. Otherwise, good luck with your questions. And yeah, that's it. See ya.